Okay, we're going to look at some calculus with polar equations. So let's start with the derivative. So first of all, a polar equation can be written parametrically. We talked about this a little bit in class, but to find the x value, that's r times the cosine of theta. To find the y value, that's r times the sine of theta. So if we're thinking about this parametrically, then the first question says, write the polar equation r equals 3 in parametric form, then find dy over dx. Why don't you try that? See if you can do both of those parts. And you can see the next question, so if you're feeling awfully feisty, feel free to try the next one, but I won't do that right off the bat. All right, go give it a try. Welcome back. Okay, I'm going to write this polar equation, r equals 3, in parametric form. So to do that, I'm going to find x, I'm going to take the value of r, the function of r, which is 3, and multiply it by the cosine of theta. I'm going to take the function of r and multiply it by sine of theta to find y. And just like in parametric equations, in order to find dy over dx, that's going to be the change in y with respect to theta over the change in x with respect to theta. So not t in this case, but still a second parameter. Okay, so I'm going to find the derivative of y with respect to theta. The derivative of 3 sine theta is 3 cosine theta. And the derivative of x with respect to theta is the derivative of 3 cosine theta, which is negative 3 sine theta. I can simplify those 3's to make this cosine theta over negative sine theta. And if you want to, you can change it to negative cotangent, but I'm not going to because I'm going to use it in the next question. Okay, so now the next question says, write the polar equation of the line tangent to r equals 3 at theta equals pi over 2. So I'm going to write this two different ways. I'm going to do this by writing the rectangular equation first and then converting that to polar. So let me show you what I mean by that. I'm going to find y equals mx plus b, or I will put it in point slope form. Okay, to do that, I know dy over dx. Oops, I'm still in highlighter mode. Dy over dx is cosine of theta over negative sine theta. So this will be the slope of the equation. I know in this case that theta is pi over 2, so the cosine of pi over 2 over the negative sine of pi over 2. Well, this one's kind of not super interesting because the cosine of pi over 2 is 0. 0 divided by negative 1 would still be 0. So I know that the slope of this line is going to be 0. It's a horizontal tangent line. The other thing I need to find is the x and the y value. So if I know what x is 3 times the cosine of theta. So in our case, x of pi over 2 is 3 times the cosine of pi over 2. Well, we just figured out before the cosine of pi over 2 is 0, so the x coordinate is 0. Now if I find y of pi over 2, I'm going to take 3 times the sine of pi over 2. All right, so I get y equals 3. This is a horizontal line because the slope is 0. Pardon me. So the equation of the horizontal line, I mean, if we write it all out in point slope form, y minus y1 equals the slope times x minus x1, so it's y equals 3. But the question said write the polar equation of the line that's tangent, so I need to write an equation in polar form, so I need to be r equals something. Well, if I know that y equals 3, I also know that y equals r times the sine of theta. Oops, y is 3. So I can solve this equation to find r. R is 3 over the sine of theta. That is the horizontal tangent line. This is the polar equation for the horizontal tangent line. Here's the rectangular equation for that horizontal tangent line. Okay, let's try another example. I'm going to use a different color now because that one is bland. I'm going to just stop at this one. A polar curve is given by the equation r equals 10 theta over theta squared plus 1. And that's only for theta values that are greater than or equal to 0. So what is the instantaneous rate of change of r with respect to theta when theta equals 2? So be very careful on this one. We're going to read the directions again. What is the instantaneous rate of change of r with respect to theta? So think about what variable we're looking for in this case. The rate of change of r with respect to theta. So the variable we're looking for in this case is dr over d theta, not dy over dx. I didn't ask for the slope of that line or the line tangent to the curve. I just want to know, how is r changing as theta is changing? With this information, see if you can figure out what I'm trying to say here. See if you can solve this problem. Okay, welcome back. So all this is saying is find the derivative of this equation. Find the derivative of that theta, 10 theta over theta squared plus 1. And we're differentiating with respect to theta, so it's like x. I'm going to need to use the quotient rule in this case. So the derivative of 10 times theta with respect to theta is just 10 times theta squared plus 1 minus 10 theta times the derivative of the denominator, which is 2 times theta, all over theta squared plus 1 squared. And the question said, find the instantaneous rate of change when theta equals 2. So at that angle. So I'll just plug 2 in and solve. So let's see, this is 2 squared plus 1, that's 5. 10 times 2, so that's 20 times 4 over 5 squared. So if I simplify, that's 50 minus 80, which is negative 30 over 25. And of course that can reduce if you want, but it's not necessary. So there's the rate of change. That's how the radius of this polar equation is decreasing at a rate of 30/25 units per angle measure, per radian. So it's units per radian in this case. Okay, let's look at another one. Find the derivative, dy over dx, of the polar equation r equals 1 plus sine of theta at theta equals pi over 4. I bet you can do this one. Go try it. Okay, welcome back. I hope you actually did try. We need to find dy over dx. So this is kind of like we did on the very first one, but a little more complicated. So we know that r equals 1 plus sine theta. That means x is equal to 1 plus sine theta times cosine theta. So that's r cosine theta. And y is equal to r times the sine of theta. So we will rewrite this as y equals 1 plus sine theta times sine theta. You can simplify or not, it's your choice. I'm going to just leave them like this, and I'm going to use the product rule on each one. So I'll find x prime here. I'm going to write a little bit smaller. Derivative of 1 plus sine is cosine times cosine without changing it. And then plus 1 plus sine theta unchanged, multiplied by the derivative of cosine, which is negative sine. Okay, I'm going to simplify a little bit and hope this doesn't get, I can simplify this down to be something nicer. Cosine squared, and then if I distribute the negative sign, this gives me negative sine theta minus sine squared theta. If that were cosine squared plus sine squared, that would make this more convenient, but it's not, so I'm going to stop right there. Okay, now I'm going to find y prime. I'm going to actually move it down here so I've got more space. Y prime, the derivative of 1 plus sine theta is cosine theta times sine theta unchanged plus 1 plus sine theta times the derivative of sine theta, which is cosine theta. Okay, if I multiply things through here, I get cosine times sine, and then I get plus cosine theta, and then plus cosine times sine. So if I simplify this even more, that's 2 of these. All right, I'm going to find dy over dx. dy over dx is just the derivative, the change in x over the change in y. The change in x was this derivative. And then the change in x was this derivative. Okay, last but not least, they asked us to be more specific. They wanted to know the rate of change at pi over 4 specifically. All right, so I know some things about this because of the unit circle. I know that the cosine and sine of pi over 4 is root 2 over 2. All of them are root 2 over 2. And if I multiply root 2 over 2 times itself, I'll get 2/4 or 1/2. So I know that this cosine theta times that sine theta is 1/2. 1/2 times 2 is 1. Plus the cosine of pi over 4, which is root 2 over 2. Cosine squared is root 2 over 2 times itself, so that's 1/2. Minus the sine of theta, root 2 over 2. And then sine squared theta is also 1/2. So this simplifies down to be 1 plus the square root of 2 over 2, and the denominator is negative square root of 2 over 2. If you are really feeling like you want to simplify this, I can divide each of the numerators by the square root of 2 over 2. So 1 divided by that would be negative 2 over root 2. And then square root of 2 over 2 divided by itself is negative 1. You don't have to, of course. This would have been fine. But if you're feeling the need to simplify more, this one would have been okay too. All right. Let's do one more thing before we get into area. So for a certain polar curve, r equals f of theta, we know dx d theta, we know dy d theta. So it's asking for the second derivative. So I want you to think back to what we did with parametric equations and see if you can find that second derivative. Okay, welcome back. In order to find, first of all, let's find the first derivative. The first derivative is the change in y over the change in x. This is going to get ugly. We're going to have a lot of algebra going on here. So there's dy over dx. It's asking us for d squared y over dx squared. It's asking us for the second derivative. So if you'll remember back from the parametric equations, since polar equations are parametric as well, what this is asking is, what is the derivative of the derivative? This is with respect to theta. So what is the change in the first derivative over the change in the second derivative? Gosh, so sorry. Let's pretend I never said any of that. What is the change in the first derivative over the change in x? How is the first derivative changing as x is changing? Sorry, I don't know what I was thinking. So we have to think about quotient rule in this top part when we're finding the derivative of the derivative. And then the change in x, we know already, they told us that. That was cosine theta minus theta sine theta. All right, so for the numerator, we need to use the quotient rule. The derivative of sine of the numerator then, derivative of sine theta is cosine theta plus, and then we'll need to use the product rule here in order to find the derivative of the numerator. So the derivative of theta is 1 times the cosine of theta unchanged plus theta times the derivative of cosine theta. Wow, this is a big, long problem, but it's good. Okay, so here's the derivative of the numerator. We have to multiply that by the derivative of the denominator. No, we leave the denominator unchanged. Wow, I'm not going to have enough space here. So here's the derivative of the numerator. Deriv of numerator. And this is the denominator unchanged. And now I have to minus, and I'm going to do this same thing now for the denominator. So I'm going to create a little more space. I'm going to shrink this way down. Sorry about that. But it's going to be the same idea. I just need way more space. Oops, I didn't like that. Let's try it again. It is not liking being squashed down that much. Okay, sorry for that smallness, but it'll get bigger. Minus, now we take the numerator unchanged, multiplied by the derivative of the denominator. So we'll have to use the product rule on theta times sine theta again. So derivative of cosine theta is negative sine theta. We're going to use the product rule on this. So it's minus derivative of theta is 1. Sine theta, and then minus theta times the derivative of sine, which is cosine theta. Whew. All over the denominator squared. And then all over dx over d theta. If this were an FRQ, you're done, but most likely you wouldn't see something like this on an FRQ. Most likely you would see something like this on a multiple choice question. So let's see if we can try to simplify things just a little bit. So for example, in this first expression here, the cosine thetas can combine. So I end up with 2 cosine theta minus theta sine theta. And then in this one here, I can combine those like terms. So I have negative 2 sine theta minus theta cosine theta. And then these two can combine to be 3 of those. Let's just keep going. I mean, I don't just stop here because you might have a multiple choice, so don't get out of the habit of trying to simplify. So I'm going to do a bunch of foiling. I'm going to multiply 2 cosine theta and theta sine theta into all of these. So 2 cosine theta times cosine theta is 2 cosine squared. 2 cosine theta minus theta sine theta is 2 theta sine theta cosine theta. And then negative theta sine theta is negative theta sine theta cosine theta. And then minus theta squared sine squared. Okay, I'm going to shrink that a little bit. And I'm going to do the next distributive property. I'll FOIL those down a little bit. So I'm going to subtract the entire quantity of my distribution here. So negative times negative, or sine theta times 2 sine theta. And then the next one becomes theta sine theta cosine theta. And then if I distribute that one through, I'm just going to put it down here, minus 2 theta sine theta cosine theta. And then last but not least, that's theta squared cosine squared, and it's negative. I'm not going to write the denominator again for just a minute because I'm going to try to simplify this first. All right, so we've got 2 cosine squared theta hopefully things are going to start to simplify a little bit. I'm going to distribute that negative, so this becomes 2 sine squared theta. Let's see, these two are like terms. So if I combine those together, that's negative 1 theta sine theta cosine theta, but then because I'm distributing the negative, it becomes plus theta, sine theta, cosine theta, and then distribute the negative to the last one. All right, combining like terms now. I can see that I probably should have combined those two, but that's okay. I can see that this one and this one will cancel. I have 2 cosine squared theta plus 2 sine squared theta. So cosine squared plus sine squared is 1. And 2 cosine squared plus 2 sine squared is 2. So this is what I'm left with. I've got 2 minus 2 theta sine theta cosine theta minus theta squared sine squared theta plus theta squared cosine squared theta. Wow. Okay, I'm not so sure it was worth our while to simplify, but it's still a good practice. Way to stick with me. If you didn't, I get it too. Anyway, have a good day. Watch the next video.